Hi class, this is section 5-7. Our key topic here is the fundamental theorem of algebra. This is about finding all the zeros of a function. So it's about finding all the zeros. And the fundamental theorem of algebra tells us that the degree of a polynomial tells us how many zeros there are going to be. So the degree tells us how many zeros. So like when we studied quadratics, our highest exponent was 2. So our degree was 2. That was our second degree polynomials. And we had two solutions. We've looked previously on the last lesson where our power was, I believe it was 5, and we ended up with 5 solutions. Actually, our power was 3, and we ended up with 3 solutions. So looking at your power, the highest exponent, that's your degree. So for example, this one right here, my degree is 4. So I should have 4 zeros. This one, my degree is also 4. So I should have 4 zeros. So one way that we are going to use to find our zeros is simply by graphing. So if you plug this expression into your graphing calculator and graph it, you will get a graph. I'm going to sketch it right here. So put it into y equals and graph it. And you'll get a graph that goes through right about here, and right about here, and right about here, and then it goes back up about here. So our graph looks something like, and I'm trying to sketch it. I'll make it look as pretty as I possibly can. It looks something like this when you graph it. But if you look carefully, this value is -1. This value is +1, this value is +2, and this value is +4. And if you look on your table, those values will actually be -1, 0, 1, 0, 2, 0, and 4, 0. So we know those are exact zeros. So our zeros are -1, 1, 2, and 4. And looking at this degree, it's degree 4, so we should have 4 zeros. So we found all our zeros just by looking at the graph. So we're graphing it. The second step is synthetic division. We don't need to, because all 4 zeros were on the graph. So one way to find our zeros is just by looking at our graph, looking at all our x-intercepts. But the issue comes about when we have zeros that are not real. Our graphs will only show us real zeros. So let's look at this second problem here. If you take and put this into your graphing calculator, we've got a degree 4, so we should expect to have 4 zeros, because our degree is 4. And if you plug it into y equals in your graphing calculator, you'll see a graph that looks something like this. It goes through at these 2 points, and it looks something like that. And if you check your table, it'll tell you -1, 0 is a 0, and that 1, 0 is also a 0. So we've got 2 zeros. We've got -1 and +1. We know those both go into this function evenly because they are zeros. So now we know we're looking for 2 more zeros. We're going to have to use synthetic division to do that, to find our 2 imaginary zeros. So I'm first going to take -1 and use -1 with synthetic division on my polynomial. So I have x to the 4th as my first power, so I need a 1 there. My x to the 3rd is missing. See, I go x to the 4th, x to the 3rd is missing, so I need to put a 0 in to hold that spot. X to the 2nd has 15, so I need a 15 there. Just a plain x, well, there's no plain x, so I need a 0 to hold that spot again, and then my constant is -16. So let's use our synthetic division. We'll drop the first one down. -1 times 1 is -1. 0 plus 1 is -1. -1 times -1 is +1. 15 plus 1 is 16. -1 times 16 is -16. 0 plus -16 is -16. Negative 1 times negative 16 is positive 16. Negative 16 and positive 16 is 0, so that's my remainder. So I now have the expression. If I drop my exponent down 1, I start with x to the 4th. Now I'm going to have 1x to the 3rd minus 1x squared plus 16x minus 16 is my constant. So there's my new expression. I need to do synthetic division one more time because I know positive 1 is another 0. So I'm going to do that right here. So I'm going to use the 0, positive 1 now. And my first coefficient of x to the 3rd is 1. My second is negative 1. My third is 16. My fourth is negative 16. So those are my numbers. Let's use synthetic division here. Okay, move this 1 down. 1 times 1 is positive 1. Add those together. Negative 1 plus 1 is 0. 1 times 0 is 0. 16 plus 0 is 16. 1 times 16 is 16. Negative 16 plus 16 is 0. So now this first 1 goes, if I drop my exponent one more, that's x squared. So I have x squared plus 0x. So I don't need to write that. So x squared plus 16. And now I've got my function there. It's simplified. Now x squared plus 16, I can easily set that equal to 0 and solve it. So I've got x squared plus 16 equals 0. And I can solve it from here. So I have x squared equals negative 16. And if I take the square root of both sides, I get x equals positive or negative. I took the square root, so I got to do positive or negative. 4, because the square root of 16 is 4, and to take care of that negative sign, I need to include my I. So my other two solutions are positive 4i and negative 4i. And those two, notice, come in a pair, because I got the positive or negative. I took the square root, so I need to have two of them. So our so what, what's important to understand about this is between graphing and synthetic division, we can find all our zeros. And our degree tells us how many zeros we're going to have. Let's look at the next side of the page. So our key topic is still the fundamental theorem of algebra, and this is about finding all our zeros. And the fundamental theorem tells us how many zeros there's going to be. It's going to be what our degree is. This first problem right here, the degree is 4, so we're going to have 4 zeros that we should expect to see. So first start by putting it in your graphing calculator. And if you put this one in your graphing calculator, it's going to look something like this. It'll go through, and I'm going to make mine a little bit bigger so I can graph it a little bit nicer for you. Okay, so when you graph this, it's going to go through right around over here. It'll go right through around right in the middle, and it'll go through right over here. So our calculator graph is going to look something like that. Okay. Now it's kind of hard to see exactly, but this value right here is negative 1/2. Okay, and we can talk in class about how to tell that is exactly negative 1/2. That if you put it in, and you can, there's a way to look in your table that negative 1/2, 0 is an exact value. So because our graph just touches right here at negative 1/2, it touches, so it goes up and down. That's a vertex. So negative 1/2 happens twice. That counts as 2 of our zeros. And that's because it just touches it and then it goes back down. It touches at a vertex. So now we're going to use synthetic division. And because it happens twice, we need to do negative 1/2 into our function twice. So I'm going to divide negative 1/2. Okay, I'm using synthetic division. My coefficients are 4, 4, negative 11, negative 12, and negative 3. And I'm not missing any, so I don't need to fill any zeros in there. My first one I'm going to drop down. Negative 1/2 times 4 is negative 2. 4 plus negative 2 is 2. Negative 1/2 times 2 is negative 1. Negative 11 plus negative 1 is negative 12. Negative 1/2 times negative 12 is positive 6. Negative 12 plus 6 is negative 6. Negative 1/2 times negative 6 is positive 3. Negative 3 plus positive 3 is 0. So this really is 4x to the third plus 2x squared minus 12x minus 6 equals 0. But I need to divide negative 1/2 into this again. So I'm just going to rewrite my coefficients. That's really all you have to do. So let's do this one more time. Synthetic division again. Drop your first 4 down. Negative 1/2 times 4 is negative 2. Negative 2 plus 2 is 0. Negative 1/2 times 0 is 0. Negative 12 plus 0 is negative 12. Negative 1/2 times negative 12 is positive 6. Negative 6 plus 6 is 0. So this originally up here was x to the fourth, so this would have been x to the third, so now this is x squared. So this really is 4x squared. This would be my plain x, so here's my constant, minus 12. So 4x squared minus 12, and that equals 0. Now, since there's no x term, I can just solve using square roots with this problem. So I want to solve this. So I'm going to solve it using square roots. So I'm going to add 12 to both sides first. So I have 4x squared equals 12. Divide both sides by 4. X squared equals 3. Take the square root of both of them. So x equals positive or negative square root of 3. So my final two zeros are the negative square root of 3 and the positive square root of 3. And we can see these on our graph right here, but we can't find their exact values without using synthetic division. So this allows us to find our exact values. Let me move my frame over a little bit. Now we're going to write polynomials when we're given what the zeros are. So if I know these are my 3 zeros, I know that I'm going to have x minus 1 as one of my terms. So I have x minus 1, because 1 would make that a 0. I also am going to have x minus 2, because positive 2 would be a 0 of that. And then I'm also going to have times x minus 3, because positive 3 would be a 0 of that. So now I need to multiply these all together and do some simplifying. So I'm going to ignore that x minus 3 first. I'm going to use FOIL. I'm going to give this x to both. Then I'm going to give this negative 1 to both. So x times x is x squared. X times negative 2 is negative 2x. Negative 1 times x is negative 1x. And negative 1 times negative 2 is plus 2. So that's really x squared minus 3x plus 2. Now I need to multiply that by x minus 3 still. So again, I'm going to distribute. Give everything in the first set of parentheses to everything in the second set. So I'm going to do x squared times x and x squared times negative 3. So x squared times x is x to the third. I'm going to write it over here so I have space. X squared times negative 3 is negative 3x squared. Now I'm going to give the second thing to everything. Negative 3x times x, negative 3x times negative 3. So negative 3x times x is negative 3x squared. Negative 3x times negative 3 is plus 9x. Now I'm going to give the final thing 2 to both of these. 2 times x, 2 times negative 3. So 2 times x is plus 2x. 2 times negative 3 is minus 6. So simplifying that, combining all my like terms, I have x to the third. Then I've got negative 3x squared and negative 3x squared. That's minus 6x squared. Then I've got 9x plus 2x, which is 11x. And then my final term is minus 6. That does not have any like terms, so there is my simplified form. So with the given zeros, that would be our polynomial. All right, in this next problem here, my zeros are 4, negative square root of 5, and positive square root of 5. Now, I want you to notice I've got both of these. I'm always going to have both of those. Just like on the previous problem that we did, we had negative square root of 3 and positive square root of 3. That's called a conjugate pair. You've got the positive and negative of the same thing. And we're always going to have that because when you take the square root, you get a positive and a negative. So my zeros are going to be x minus 4. And then we're going to have x plus the square root of 5 and x minus the square root of 5. Now, if I multiply these last two out, what's going to happen is I'm going to have negative 5x, or negative square root of 5x, and positive square root of 5x, and those will just cancel out. So I'm going to have x times x, which is x squared. The square root of 5 times the negative square root of 5 is going to be minus 5. So foiling those out, really I don't need to take all that time. It's just going to give me x squared. My middle two terms of the FOIL are going to cancel out. I'm going to be left with minus 5. And I still need to multiply this by x minus 4. So let's use FOIL. X times both of those terms. So x times x squared is x to the third. X times negative 5 is negative 5x. Now I've got negative 4 times x squared, that's negative 4x squared. And I've got negative 4 times negative 5, which is plus 20. Now this is not in standard form, so I need to put it in standard form. I'm going to have x to the third. My next is minus 4x squared. My third is minus 5x, and my final term is plus 20. And there is my simplified form. Okay, so again, I've got zeros here. So I'm going to have x plus 1 as one of my zeros. And I'm going to have x minus 2 as one of them. And then this last one, I've got minus 3i. Okay, so I stands for the square root of negative 1. So this is really a square root problem again. And this must come in pairs just like this must come in pairs. So we're going to have to say x plus 3i and x minus 3i. We have to have a pair when we've got this as one of our zeros. So I need to have x plus 3i and x minus 3i. And again, that's because they must come in pairs since I stands for the square root of a number. So now our last two, if we multiply these last two together here, what's going to happen is our middle two terms are going to cancel out. So I will just be left over with x squared plus, now if I think of 3i times negative 3i, that would give me negative 9i squared. Well, I squared is negative 1. Negative 9 times negative 1 is plus 9. So multiplying x plus 3i times x minus 3i is going to give me x squared plus 9. Let's multiply these first two together. So x times x is x squared. X times negative 2 is negative 2x, and 1 times x is 1x. So I've got negative 2x and 1x. So far I have x squared, negative 2x, plus 1x is negative 1x. And then my last term, positive 1 times negative 2 is minus 2. So there's my two things I need to multiply together now. So I'm going to take and multiply x squared by both of my terms. So x squared times x squared is x to the fourth. X squared times 9 is plus 9x squared. Next, I'm going to have negative x times both of them. So negative x times x squared is negative x to the third power. And one thing I showed you in the other one, this one, if I want to try and put it closer to standard form, I could write that minus x to the third, kind of in the middle right there. Negative x times a positive 9 is negative 9x. So I'm going to write it right here. Then my last one, negative 2, I need to give negative 2 to both of these. So negative 2 times x squared is negative 2x squared. I'm going to write that right here because it'll go with 9x squared. Negative 2 times 9 becomes minus 18. So now I've kind of got it lined up in the right form. So x to the fourth is my first term, minus x to the third. 9x squared minus 2x squared is plus 7x squared. That minus 9x doesn't have a like term, and the minus 18 doesn't have a like term. So here is my simplified form. So what's important to understand is that there's an extra piece that we added here. I want you to remember. So we're going to put extra here. If a 0 touches the x-axis, then it occurs twice. Okay, so we have the zeros that touch the x-axis occurring twice. And then another thing that you should also remember is like right here and right here, we have our conjugate pairs here. They must come in pairs. So please make sure if there's any questions, you star them so we can talk about them in class, and have a great night.